Somewhere in your brain right now, there are memories you can't access. Not because they were never made, not because they were erased, but because the key to unlock them no longer exists. Scientists believe some of your earliest experiences, your first face, your first fear, your first word, are still encoded somewhere inside you. You just can't reach them. And understanding why changes everything you thought you knew about memory, identity, and who you actually are. This is the story of infantile amnesia, and the answer science just found is stranger than the question. Here's what we know. You lived an entire life before the age of 3. You opened your eyes. You felt hunger. You heard your mother's voice for the first time. You learned to walk. You learned to recognize faces. And you remember none of it. Most people assume the explanation is simple. Your brain was too immature, like a camera with no film. Nothing got recorded, but that assumption, the one almost everyone has made for over a century, is wrong. And in 2025, a team at Yale University proved it. We've known for decades that infant brains can form memories. In the 1980s, psychologist Carolyn Rovi Collier at Rutgers tied a ribbon from a baby's ankle to a mobile above their crib. The baby kicked, the mobile moved, and the baby learned within minutes. When brought back days later, they kicked immediately. 6-month-olds remembered for weeks. So your infant brain wasn't empty. It was recording. The question was never whether memories formed. The question was, what happened to them? The first part of the answer is brutal in its irony. In 2014, neuroscientists Sheena Jocelyn and Paul Franklin at Toronto's Hospital for Sick Children discovered something almost cruel. The same process that was building your brain was also destroying your memories. Here's what they found. In the first years of life, your hippocampus, the brain's memory hub, produces new neurons at a staggering rate. This is called neurogenesis, and it's essential for development. But every new neuron that integrates into an existing circuit rewires the connections that were already there, the connections that were holding your memories. When they artificially increased neurogenesis in adult mice, those mice forgot things they'd previously learned. When they slowed neurogenesis in infant mice, those mice held onto memories far longer than normal. Your brain wasn't too weak to keep your memories. It was too busy building itself. And building, it turns out, requires demolition. But then came a discovery that reframed the entire mystery. For decades, the leading theory was that infant memories simply couldn't form properly in the first place, that the hippocampus was too undeveloped to encode experiences at all. Case closed. In March 2025, Tristan Yates and Nicholas Turk-Brown at Yale University published a study in the journal Science that challenged that assumption directly. Instead of relying on behavior or verbal recall, impossible with pre-verbal infants, they did something no one had managed before. They put babies in an fMRI scanner while they looked at images and watched their hippocampi in real time. What they saw was striking. Babies as young as 12 months showed clear hippocampal activity during memory encoding, distinct neural patterns for images they would later recognize, compared to images they wouldn't. Their brains weren't failing to record, they were recording precisely. The problem wasn't storage, it was retrieval. The memories were there, but the pathway to access them was gone. Turk-Brown called this possibility almost sci-fi. That some of your earliest memories may still exist inside you, in some form, in adulthood. Not accessible, not erased, just locked behind a door for which the key was lost long ago. But there's a second layer, and it's more philosophical than biological. To form what scientists call autobiographical memory, the kind where you are the main character of a story you can replay, you need something most people take for granted: a self, a sense that things are happening to you. Developmental psychologists Mark Howe and Mary Courage argued that before roughly 18 months, infants don't experience themselves as distinct individuals. There's no narrator inside. The classic test: put a dot of rouge on a baby's nose, place them in front of a mirror. Before 18 months, they reach toward the reflection as if greeting a stranger. After 18 months, they touch their own nose. That moment, self-recognition, maps almost perfectly with the earliest point at which autobiographical memories can form. In other words, you can't remember being a baby partly because there was no you yet, not in the sense you understand yourself now. And then language. Psychologist Catherine Nelson found that once children begin having conversations with adults about shared past experiences, remember when we went to the beach? Their ability to hold lasting memories improves dramatically. Language doesn't just describe memories, it gives them structure. Without words, experiences are like water. They exist in the moment, then dissolve. Psychologist Chi Wang at Cornell confirmed this culturally. Among the Maori of New Zealand, whose oral tradition places extraordinary emphasis on personal history, Average first memories reach back to age 2.5. In cultures where early narratives focus less on the individual, first memories often start closer to age 4. The culture you're born into shapes how far back your memory reaches. So here's the real picture. Your hippocampus was encoding memories earlier than we ever thought. But neurogenesis, the very act of brain growth, was rewiring the circuits that held them. You had no self to anchor experiences to, and no language to give them shape that could survive. But the part that's hardest to shake is this. The memories may not be gone. The 2025 Yale study suggests they could still be in there, dormant in hippocampal circuits that the adult brain can no longer reach through natural recall. Turk Brown's team is now tracking whether any trace of infant hippocampal memories survives into adulthood. Early results suggest some may persist until age 3 before fading. But the possibility that they endure even longer hasn't been ruled out, which means the baby in your old photographs might be more connected to you than you realize. Not a stranger who wore your face, not a self that was dismantled and replaced, but an earlier version of you whose experiences are buried somewhere in the architecture of the brain you're using right now to read these words. You just don't have the key yet.